Hi class, this is Sir Alex again. Welcome to our lesson in General Physics 1. Today we are discussing lesson 5.2, still connected with work, but this time we are discussing energy. So today we are going to know what energy is and how we can solve for energy. So the goal of today's lessons include for you guys to be able to relate the gravitational potential energy of a system or object to the configuration of the system. Also be able to relate the elastic potential energy of a system or object to the configuration of the system. And lastly, use potential energy diagrams to infer force, stable, unstable, and neutral equilibria and turning points. So let's begin our discussion by asking ourselves, what is energy? As we have discussed work before, work is basically force, or this is the dot product between force and displacement. Energy is basically the ability to do work. A system that has a energy or possesses an energy has the capability to do work, meaning a system that has energy can basically use force to displace object. So for example, a person has energy in order for them to do work or to apply force onto an object. For example, we've done a lot of these examples, pushing crate or pushing rocks. But a person having the energy in order to exert a force onto a rock and being able to move that rock or that box that they're trying to push is a person that has energy and they're capable to do work. Energy is also expressed in terms of joules, so we use joules, which is a scalar quantity. So energy is a scalar quantity similar to force. And there are different types of energy, different types of forms, or different forms of energy. We have mechanical energy, which also heat energy. We also have light and even chemical energy. So we're not going to focus heavily on each of these examples, but we're going to focus on two examples, potential energy and kinetic energy. So let's begin discussing potential energy. Potential energy is basically the energy that can be possessed by a body because of its position or configuration. What do we mean by that? So potential energy can be classified as energy possessed by the body depending kung ano yung position niya or ano yung configuration niya. An example of this is gravitational potential energy. Gravitational potential energy is energy due to the position of an object. One example of this is anything that you raise, no? Kapag halimbawa yung bola, you lifted a ball up, we know that the ball, once it released, it will fall to the ground. That is because it has a gravitational potential energy. Once you raised an object with a mass above, once you raise its height, mm, it will always fall down because as you raise it up, as you raise that object with the mass up, it stores what we call a gravitational potential energy. And once it's released and it starts to move, it uses that gravitational potential energy to convert it into kinetic energy. Kinetic energy, which is the energy related to movement. We have discussed this a lot of times. But the reason that, for example, you have a swinging ball right here, the reason that it goes back down is because as it goes up and it reaches that maximum height, now as it goes up, it is storing a gravitational potential energy. And it uses that potential energy to do work, to in order for its weight to exert a downward force and its displace and it having a displacement. No? And we can measure the gravitational potential energy of an object that we raise depending on the mass of the object multiplied by the acceleration due to gravity and the height. So it depends. So gravitational potential energy depends on three things: the mass of the object, the weight of the object, or the um, acceleration due to gravity, which is 9.8 meter per second squared, and the height. So kung gaano mo siya, um, how high you raised that object. So the higher the object is, the bigger the potential energy, no? And the next part, which is included in potential energy, is what we call elastic potential energy. Elastic potential energy is the energy due to the configuration of an object. If gravitational potential energy is due to position, elastic potential energy is due to its configuration. So what do we mean by configuration? So ito yung kumbaga itsura ng object, no? How the object is formed. One example of this is springs and the strings on a bow, yung mga goma, anything that is basically elastic, no? The strings on a bow, yung goma na minsan ginagamit mo pampitik sa kaibigan mo or pang inis lang, no? Or pang tali na buhok mo, all of those has elastic potential energy. And that potential energy is due to the configuration of an object. So for example, we have a spring. Once you compress that spring and release that spring, you know that spring will go back to its original shape. And the same thing if you pull that string now, if you pull the string, for example here you pull the string, once you pull that string, you're storing potential energy in the spring. And once again, if you release it, it will go back to its original shape. And due to the movement of that spring, no, it changes length. So it changes, you can think of it as also changing displacement. So we can measure the potential energy of an elastic object. For example, a spring, rubber, the strings on a bow, no, so bow and arrow. All of those contains potential elastic potential energy when you change their configuration, when you compress them, or when you stretch them. And we can measure that potential energy by 1/2 multiplied by kx squared. X is however the length of however you compressed or you stretch that spring. No? For example, you have a spring of let's say 5 centimeter spring, and then you hold the springs on both ends and then you stretch it, creating making the spring, let's say 8 centimeters. So from 5 centimeters to 8 centimeters, now the string is 8 centimeters. So the potential energy is stored with kx squared. So the x there is actually 3 centimeters because the original length is 5. You stretch it to 8 centimeters. So you stretch it now more. So you basically have to multiply 1/2 and k. K is a what we call force constant. Force constant is depende dun sa object, depende dun sa string, depende dun sa rubber mo. And it is usually given. And this is a measurement of how stiff the object is. The higher the force constants or the higher the k is, the harder it is or the harder it is to change the configuration. And once you're able to change the configuration, the more potential energy it stores. I hope that is clear. But gravitational potential energy and elastic potential energy are basically energy that the body can possess depending on its position and its configuration. So for gravitational potential energy, if you change its position, basically by increasing its height, it can change or it can store potential energy. As for elastic energy, halimbawa yung goma, by stretching yung goma, or for example, the spring, again, by compressing the spring or by stretching the spring, you are storing elastic potential energy that can do work. Lastly is what we call the kinetic energy. So kinetic energy is the energy possessed by a body because of its motion. So once that object starts moving, it can possess what we call a kinetic energy. And its kinetic energy is due to its motion. And we can solve for that kinetic energy by multiplying the mass to the velocity of the object squared multiplied by 1/2. So these are the equations that I want you guys to remember. For potential energy, specifically gravitational potential energy. We can measure the potential energy by multiplying the mass to the acceleration to the gravity multiplied by height of the object. We can measure the potential energy of a spring or any elastic materials by 1/2 multiplied by force constant multiplied by, however, the length of the object, which is x squared, or however how much you compressed it or how much you stretched it. No, K is a force constant that is a measure of the stiffness of the object or the spring or the rubber. So this is usually given unless this is the one you are solving for. And later we will discuss this even more. And lastly, we have kinetic energy, which is the energy possessed by a body depending on its motion. So nakadepende siya sa kung gaano kabilis yung motion. The higher the speed is, so mas mabilis yung object, mas mataas yung kinetic energy niya. Now let's try these sample problems in order for us to apply what we have learned about potential, elastic potential energy, specifically gravitational and elastic, as well as kinetic energy. So let me just use my pen. Okay, so sample problem 5.2.1. A 7-kilogram child climbs a 6-meter long slide that is inclined 30 degrees with the horizontal. What is the potential energy of the child with respect to the ground? So let's write our given. We have a child with a mass of 75 kilogram, and the length, so this is not the height, no, this is just the length of the slide, is 6 meters long, and this slide is angled at a 30-degree angle. So what are they asking us is the potential energy of the child. Since it's the child that increases its height, no, nag-change na position, we are looking for the potential energy of the child. The formula that we have to use in order for us to find the potential energy is the formula that I showed you earlier for gravitational potential energy. This is PE is equals to mgh. Solution. So how are we going to solve this? Well, what we lack in our information is we have the mass and we know the g. But what we do not know is the h, right? So first what we have to do is solve for the height. And how we can solve for that? Basically, let's do a diagram on what is happening. So we have a slide that is 6 meters long, so meaning we can think of this as our slide, no? So this is our slide, and we know that this slide is 30 degrees, is angled 30 degrees to the ground. So, and ito yung, kumbaga, yun yung, second, ito yung ladder para pumalik ka dun sa slide, no? So this is 6 meter long, this is 30 degrees. So the height that we were looking for is this area right here. This is the height, no? So pumanik yung bata, so the child, basically the child went up on this slide, no? So you want to find the height. So how are we going to do that? Simple trigonometry. If we have one side of a triangle, as you can see, this is a right triangle. If you have one side of a triangle and an angle, we can use trigonometry to find the height. And the height here is basically, height is equals to, this is basically the hypotenuse, which is 6. And since it's on this side, that is opposite to the angle, that is basically sine 30 degrees. So using trigonometry, I hope you guys remember how to find the length of an Triangle if we have the hypotenuse and one of its angle. So the opposite angle, that's basically SOHCAHTOA. Um, you can solve for the height, no? So, sige, I'm gonna explain so you might not get confused how did that happen. Okay, so I want you guys to remember SOHCAHTOA. So the information that you have here, you have the hypotenuse. So we're not gonna use TOA, but what you have is one of its angle or one of its side, the hypotenuse, and an angle. No. So what we want here is um, is to find the height of an angle. Since we have the hypotenuse and we have an angle, so if we use cosine, so we know that cosine angle is adjacent over hypotenuse. Unfortunately, since this is our angle, this should be the adjacent side and this is the hypotenuse. But what we're looking for is not the adjacent because the adjacent is here. It's not the height that we're looking for, so um, we cannot use cosine. What we ended up is using sine because we know that sine of an angle is equals to opposite divided by the hypotenuse, no? So we have the angle here and the opposite of that angle is basically the height. So what we ended up having is we have the height, which is the opposite side, the hypotenuse, which is 6, and we have sine 30 degrees. So in order for us to find sine, it's basically h over 6 meters. In order for us to find the height is equals to, we have to multiply both sides by 6 meters. 6 meters, cancel 6 meters. You ended up with having 6 meters multiplied by sine 30 degrees. So that's how you can find the height. And measuring the height, 6 sine 30 degrees is actually equal to 3.0 meters. So now that we find the height, we can solve for the potential energy. Because we know potential energy is equals to the mass of the object multiplied by the acceleration due to gravity and multiplied by height. So the mass of the kid is 75 kilogram multiplied by gravity acceleration due to gravity, which is 9.8 meter per second squared, multiplied by 3.0 meters. And the meters get cancelled. You are left with kilogram. So you are left with kilogram per second squared. Kilogram per second squared is also a measurement of joules. And this is, just use your calculator to solve this. This gives us 2,205 kilogram per second squared, or 2,205 joules. So that's how we are going to solve for the gravitational potential energy. I hope it's clear. If it's not clear, I hope you guys message me so I can explain it more. So I can explain it more. Next, let's now try and solve for elastic potential energy. So a coil spring in a waste streaming exerciser requires a force of 54 newtons to compress it to 0.2 meters. So let's write our given. So we have a coil spring in an exerciser, and in order for you to compress the spring to 0.2 meters, you need a force of 54 newtons. So in order for you to compress it at 0.2 meters, you need a force of 54 newtons. And then what they're asking us is find the force constants of the spring. So ano ba yung asked? The first ask is find the force constant. Force constant is the K. And then B, they're also looking for how much force is needed to compress the spring by 0.50 meters. So how much force is needed if I want to compress the spring at 0.5 meters? And letter C, what is the potential energy when compressed at, this should be at 0.5 meters. So what is the potential energy if I compress it at 0.50 meters? The formula that we need in order for us to solve this is the one that I showed you. Potential energy of an elastic object is 1/2 multiplied by the force constant x squared. So x is, however, the length of the object. No? So how short you compressed it or how long you stretched it. Okay, so let's do the solution. One thing that I want you guys to remember, we have to find first, we have to find the force constant A. One thing that I want you guys to remember, force constant has a unit of Newton per meter. So ito yung unit for force constant, no? And since this is the unit of our force constant, that actually tells us what is the equation for force constant. Force constant, since it has a unit of newtons per meter, so as in units of newtons per meter, this tells us that the equation for force constant is force over x, because newton is a unit of force and meter is a unit of displacement. In this case, we use x as the length of the object, so m as the length of the object. So what are we going to do to find the force constant? In order for us to find the force constant, we have to use the given information. We know that in order for us to compress the object to 0.2 meters, we need a force of 54 newtons. So we have our force and the length of the object. So the K is basically, we needed 54 newtons divided by 0.2 meters. So that, and this will gives us a force constant of 270 Newton per meter. And this force constant, remember, is a measurement of the stiffness of the elastic object. So it does not change. No, this is like the word, it's a constant. So this is a number that is related to the object, and the relationship is basically this is the stiffness, measurement of stiffness of the object. So now we can solve for the next question. So how much force do I need in order for us to compress the object at 0.15 meters? So remember that the force constant is equals to force multiplied by x. And if I'm going to compress my object to 50 meters, how much force do I need? So we can just rearrange the equation, kx, and that gives us how much force that I need in order for me to compress the spring to 0.5 meters. So the force constant is 270 Newton per meter multiplied by 0.15 meters, and this cancels out, and the force that I need in order for me to compress it to 0.5 meters is just 135 newtons. So I need a force of 135 newtons in order for me to compress the coil spring to 0.50 meters. And lastly, now we can solve for the potential energy. We know that the potential energy of an object is equals to 1/2 kx squared. And the potential energy of the object, if I compress it at 0.50 meters. So I can just take 1/2 multiplied by its force constant of 270 Newton per meter multiplied by 0.50 meter squared. So this becomes m squared. That gives us Newton meter as our units. And this actually gives us a potential energy of 33.75 Newton meter. Newton meter, that's what's left because this is m squared, so one of the m gets cancelled. We're left with m on the numerator multiplied by the n on the numerator. That gives us Newton meter. And Newton meter is a measurement of joules. So 33.75 joules is the potential energy of the coil spring if you compress it at 0.50 meters. Okay, so I hope that is clear, and you can also solve for how much potential energy the spring has if you compress it at 0.20 meters. You can just follow this example, just changing the meter to 0.20. We're not going to do that because it's not asking us anyway. But that's how you measure the potential energy for an elastic object. Now let's move to kinetic energy. Like we've mentioned, kinetic energy is the measurement of energy of an object based on its velocity, so based on its movement. So let's have this question. Which has a greater kinetic energy? A 2 kilogram mass a 2 kilogram mass moving at 3 meters per second squared, or a 1 kilogram mass moving at 6 meters. So our given, we have a mass 1 of 2.0 kilogram, and this mass 1 is moving at the velocity of 3.0 meters per second. We were also given a mass 2 of 1 kilogram, and this mass is moving at a speed of 6.0 meters per second. And what's asking us is the potential or the kinetic energy for mass 1 and the kinetic energy for mass 2. And we know that the formula for kinetic energy is 1/2 mv squared. So kinetic energy is equals to 1/2 mv squared. So let's head on to the solution. Let's begin with m1 first. So let's begin with mass 1. So for mass 1, the kinetic energy of mass 1 is equals to 1/2 m1 v1 squared. So the kinetic energy is equals to 1/2 multiplied by the mass of the first object, which is 2.0 kilogram, multiplied by its speed, which is 3.0 meters per second squared. Oh, meters per second only, sorry. Meters per second squared. And if you use the calculator, you would actually find that the kinetic energy for mass 1 is actually equal to 9.0 joules. Let's take mass 2, which is lighter than mass 1, but it is moving at the twice the speed. So it's moving the twice the speed of mass 1. So for mass 2, the kinetic energy of mass 2 is equals to 1/2 multiplied by the mass of mass 2 multiplied by its velocity squared. And that gives us 1/2 multiplied by 1.0 kilogram, and that is 6.0 meters per second. And then square that, and we will find that the kinetic energy for the second object is actually 18.0 joules. So let's go back to the question, which has a greater kinetic energy? Now, the second mass 2, has greater kinetic energy. And we know that this should be the case because mass 2 is moving at a higher speed compared to mass 1. So that is the kinetic energy of an object. And how we are going to solve for the kinetic energy of an object. You just need the mass of the object and how fast the object is moving. I hope that is clear. That's all about for energy today. If you guys have any question, please message me. Otherwise, have a great day.